Hi guys, Miss Summer here. We are now in chapter 8. You made it through one chapter of remote learning. We're ready to start the next. And this is section 8.1. We're going to be simplifying rational expressions. Now we know an expression does not have an equal sign. And for example, here's an expression up here in this numerator, 3x squared plus 2x minus 4. And here's an expression down here, 4x minus 5. So this is a rational expression. It means that it has an answer. It has a number. It's not undefined. So if we had a rational expression, P over Q, P being any expression, Q being any expression, Q cannot equal 0. It cannot be undefined. So we're going to be looking at quite a few quotients or fractions. We're not actually going to divide them yet. We're just going to simplify them. But for now, here are 3 different examples of rational expressions that you might see. Here, a trinomial over a binomial, or a binomial over a trinomial. Some of these can be factored, or just a simple expression over a number. So any expression, one over the other, is going to be a rational expression in this section. All right, so let's dive into first. The simplest thing that we could do is just evaluate. Evaluating is when we plug in numbers. So let's do that first. We'll just do one example. So our first example would be if x is equal to -2, let's evaluate the rational expression x minus 4 over 2x minus 3. So we would just plug it in. And we've done this before. So this is a sort of a repeat of that. -2 plus 4, 2 times -2 minus 3. So in this rational expression, we get 2 for our numerator. We get -4 here. And -4 minus 3, -7. Now, does the negative go with the numerator, the denominator, both? The way that I would type this into my math lab is put the negative sign, and then for division, put the 2 and the 7, and then you're finished. Technically, this is equivalent to -2 over 7 or 2 over -7, but we more appropriately just write that as a negative overall. It's a negative number, okay? Although mathematically, those are equivalent. All right, moving on. What are we going to do after we do a little bit of evaluating? Well, we're going to start simplifying some rational expressions. So let's begin. And keep in mind, the denominator cannot be 0. We're going to see that in just a moment. It says, are there any values for x for which the expression is not rational? So we're actually looking for circumstances where our denominator would be 0. So if we have our first example, A, x over x minus 3, the first thing we say is, well, if this was 0, if x minus 3 equaled 0, then we would have an undefined expression. So if x was 3, if we plug that in, 3 over 3 minus 3 would be 3 over 0, and this would be undefined. So our answer is 3. That would be the place where it is undefined. So moving on to another example. B. Let's try x squared plus 2 over 3x squared minus 5x plus 2. Well, first, this trinomial needs to be factored. We cannot set that equal. If we set that equal to 0, we have to factor it in order to solve it, because we know in our last chapter, when we set this equal to 0, just like we set x minus 3 equal to 0, it may be longer, but we can't solve that without a factoring. Well, we know 3 only has the factors of 1 and 3, I'm going to put my 3 up front. It does not need to be up front, but I'm going to go ahead and do that. So I've got 3 times 1. In the back, it's either 1 times 2 or 2 times 1. Well, we know our signs are going to be the same. They're both going to be negative. So my values need to add up. My outer and inner terms need to add up to -5. Now, if I put 2 here and 1 here, I get -6 and -1. That doesn't add up to 5. If I put my 2 here, my outer term is -3, my inner term is -2. That does add up to -5, my outer and inner terms. Therefore, these are the 2 terms for my denominator. Those are the 2 products. So now I set each one, instead of just having 1 binomial, I now have 2, and each of them needs to be set equal to 0, just like you did in the last chapter. And x could be 2/3, x could be 1. Now, in the last chapter, sometimes if we had a negative, we threw it out. That was only for some very specific ones. So every single answer you would accept. So both 2/3 and 1 would be numbers where this expression would be undefined. So both of them would be answers in this particular case. Okay, let's look at 2 more examples of where the instructions again would say, are there any values for x which each rational expression is undefined? That's the question. So we're looking for where it is undefined. It is super important in this section to watch and read carefully what the instructions are, because the problems look identical. The instructions differentiate what you need to do in each circumstance. So here's the next one. We're still looking for what makes the rational expression undefined. All right, so looking at this one, some of you might say, well, I can factor that numerator. So am I looking for a 0? Should I set this equal to 0? Well, no, because it's okay if the numerator is 0. But the denominator, will 3 ever be equal to 0? No, 3 is never going to be equal to 0. So will it ever be undefined? No, it is always going to be a rational expression. So the answer would be none. Usually in my method, I would give you a choice of that it's a rational expression or that there is no number that would make it undefined. Here's another. So as you learned in the last chapter, if we have 2 squares and if this was subtraction, you could factor it. But here, because it's addition, you can't factor a sum of 2 squares. You can only factor a difference of 2 squares. Some of you tried to factor that sum, but don't do it. So what does that mean? Well, since this will not equal 0, or if you do this, is it possible to take the square root of a number and get -1? No. Or to square a number and get -1? No, because any 2 numbers squared, whether they're negative or positive, will always result in a positive. So this is not even possible. So what does that mean? That means that this denominator can never be 0. If it can't be factored, it can never be 0. So again, the answer you would choose is that it is a rational expression and there is nothing that will make it undefined. All right, now that we've talked about what will make a rational expression undefined, let's talk about simplifying a rational expression. When we use the term simplifying before, for example, if you were just simplifying a fraction, you would say, oh, the highest number, 50 goes into 100 twice, so I could just reduce this to 1/2. Yes, most definitely true. Okay, so how are we going to do the same for expressions? All right, let's take our first expression, x squared plus 3x minus 4 over x squared minus x minus 20. And by the way, these are the notes from the notes in the chapter. I did attach it in your materials for this class, so you can certainly print it up, or you can take some notes as you go along. It's already in there. Sorry, I didn't say that at the beginning, but you can just zoom on back to the beginning anytime and write anything that you wish. Okay, so if we're simplifying this time, okay, simplify. That is our most important instruction there, simplify. So the first thing we're going to do is make sure the numerator and the denominator are factored completely. So in our numerator, we have x squared plus 3x minus 4. We're going to go ahead and factor that to x times x, or it can be either 1 times 4 or 2 times 2. Well, since our signs are different, we're going to have to subtract to get 3. So 1 and 4, not 2 and 2 this time. The higher number, 4, is going to be positive. The lower number is going to be the negative. So we can check first. Outer and inner gives us 3x, and last gives us negative 4. Now at the bottom, our denominator, again, x and x. For 20, we know there are lots of factors for 20. We could have 1 and 20, 2 and 10, 4 and 5. Well, which factors are going to, if we have different signs again, which factors are going to give us a negative 1? Well, it's going to be a negative 5 and a positive 4 that give us 1. So 4 here, 5 there. Well, now you may notice that we have a matching factor. Okay, we have a matching factor. If you have a matching factor, they cancel. These don't cancel. You can never cancel this x and this x. The reason is because the expression is a unit, it's a factor itself. So you can't separate or pull that apart. A factor means that it's part of multiplication. These are being subtracted, not multiplied. So x's stay together, and we end up with x minus 1 over x minus 5. And that's our final answer. Now, sometimes we'll be asked, not in every problem, you may just simplify it. Sometimes you will be asked, when is this expression undefined? So we're going back to our previous problem. When is x minus 5 equal to 0? So you just take that denominator, set it equal to 0. If you're asked when is it undefined, and then x equals 5, that would be where x is undefined. So this is your answer, and it's undefined for 5. All right, moving to another example. We have 5x minus 5. Again, we're simplifying a rational expression. 5x minus 5 and x cubed minus x squared. So this is example 3, just in case you were following along in the notes. At this point, we're on example 3. So what do we do with 5x minus 5? Take out 5, our GCF. What do we do here? We take out x squared, our GCF. Once again, we have a matching factor, x minus 1. Matching factors cancel. Now they just don't cancel to 0, they cancel to 1. And remember, 1 times anything, the 1 just goes away. So, because this is just itself. We can't do any more reducing. There are no matching factors in the numerator and denominator. So we might want to say where it's undefined. It would be undefined if x was 0. So x cannot equal 0. Simplified answer, where the number is undefined, 0. Sorry, that fell off the screen just a little bit. Next example, example 4. X squared plus 8x plus 7 all over x squared minus 4x minus 5. So again, we're going to factor it out. We've got two trinomials, so we're going to factor both trinomials into two sets of parentheses. So if you're thinking, wow, this is two factoring problems and then a simplifying problem, you're absolutely correct. All right, we've got x and x, 1 and 7 multiplied to 7, same sign, both positive. So outer and inner adds up to 8, and they multiply to 7. So we got that one done. First, x and x, they have to multiply to 5, but they both have to be different. So positive, negative signs. We know 5 is only 1 and 5. The highest sign is negative. So 5 is the highest number, so it's negative. 1 is positive. So first, outer -5, inner +1 gives us -4. And -5 times 1 gives us -5. Always check and recheck, because it gets a little frustrating when you factor something incorrectly. Now, usually you have a matching factor. So if you don't have a matching factor, try it again. Here we have a matching factor of x plus 1. And we're done simplifying. Again, we cannot cancel out the x's because the x's are part of a binomial. They're not multiplied by 7 or multiplied by -5. They are, it's addition and subtraction. They're hooked together. You cannot separate them. One of the things you can do is keep your parentheses around it to remind you that it's a unit so that you don't separate it. But you don't have to plug it in with parentheses into MyMathLab. It's totally unnecessary. And in fact, I'm not sure if they'll kick it back and say, get rid of those parentheses. They shouldn't, but they might. So now x minus 5 cannot be equal to 0. So x cannot be 5. That is where it would be undefined. All right, rolling to our next example, number 5. All right, our next example, example 5. We've got x squared plus 4x plus 4 over x squared plus 2x. And factoring that one out, there are two sets of parentheses, x and x. Now we can either have 1 and 4 or 2 and 2, but we know these are the same sign, both positive, so it's got to be 2 and 2. That's what adds to 2. Plus, if you notice the perfect square, and those two perfect squares, x and 2, multiplied together and double this 4x. That's how we know it's a perfect square. So at the bottom, we have an x that can come out, and we get x plus 2. So can we get rid of both x plus 2's? No, we can only get rid of one. This only cancels out one of them, not both of them. So be careful if you write like a square at the top for that instead of writing x plus 2. So if you wrote it this way, okay, you might want to say, hey, that went away. It's x to the first now, okay? But don't make sure if you do write it as a square that you don't cancel the parentheses and then think you don't have anything left in the numerator. You do. So what we have left in the numerator is x plus 2. What we have in the denominator is x. Again, the x's do not cancel out, and x is not equal to 0. It would be undefined at 0. And again, do we need these parentheses? We do not. But I don't want you to think you can cancel the x's. All right, so let's move on again to another situation. I talked earlier about a difference of two squares. Let's look at that again. A difference of two squares will factor into conjugates. So we want to recall what those are. It's a difference because it's subtraction, and this is a perfect square, and this is a perfect square. Remembering that the square root of x squared is x. The square root of 81 is 9. So numerator is x plus 9. Denominator is x plus 9, x minus 9. These are conjugates. Same binomial, but different sign. One is a sum, one is a difference. That's what happens when you have a difference of two squares. We can cancel these out. You're like, well, is the numerator 0? No, because things don't cancel to 0, they cancel to 1. So we end up with 1 over x minus 9. And since x minus 9 cannot be 0, then x cannot be 9. So simplified answer, this is what makes it undefined. Will they always ask what makes it undefined? No, but when they do, you'll be prepared. All right, we have 3 more examples. Now, this one adds a little twist eventually. All right, in example 7, this was example 6, we have x plus y and y plus x. Well, addition is commutative. So x plus y, this is equivalent. So they cancel, and our answer is just 1. Make sure you write it as 1. My math lab will count off as if you write it as 1 over 1. And if they ask you if there's any place where it's undefined, it's never undefined because it's not divided by a variable or variable expression. Now, contrast to that. We can't just flip this over because it's not commutative. Imagine if this was 5 minus 3, that would be 2. But 3 minus 5, that would be negative 2. So what do we do to compensate to make sure that it is equivalent? Well, the rule is this. You can flip it if you take out a negative. So we're going to put a negative out front. And we're going to put it out front here. If you put it in the denominator, you want to put parentheses around it. It's much easier to just put it in front of the whole problem. Now, why are we allowed to do that? Well, let's take a look at this for a second. If we flip it over, the negative is attached to the x. The positive is attached to the y. That's not what we want. We want a negative here. So if we factor out a negative, now we have x plus y. So factoring out a negative. So to get that negative, what happened is we factored out that negative. So what results is flip it, put a negative out front, and you've got that covered. You don't want to have to go through this whole sequence of switching them and then factoring out a negative and then plugging that into your problem. Just flip it and put a negative. But remember, if it's positive, no negative is necessary. You could just flip it straight away. All right, so, and here you can say x minus y is not equal to 0, but technically we can't say what number that would be. We can say that x cannot equal y. They can't be equal to one another. That's about all we can do as far as is it undefined or not. Okay, now in this case, by the way, we didn't finish the problem. These cancel, but there's a negative here, so this would be -1. So as far as our expressions go, this one would be 1. This one would be -1. Okay. Here, x plus y, talking about being undefined, cannot equal 0. So what that means is x cannot equal -y. We can't have opposites here. Here we can't have the same number. 2 more problems and then we'll be all finished with the explanation. All right, so the next one, 4 minus x squared. This is example 8. And in the denominator, 3x squared minus 5x minus 2. While I'm here, I'm going to go ahead and write up the next example on the side, example 9, and write negative 5x minus 1 over x plus 9. And we'll get to that one in a moment. So the first one, notice that x squared is in the back. Can you factor that out? I mean, it is a difference of 2 squares. Can you do, 2 minus x and 2 plus x? Sure. But then you got all this awkward flipping that has to be done later. So I'm going to go ahead and flip it now and say, okay, I can flip these over. If I flip it over and it's subtraction, I can take out a negative and just flip it like so. This is now positive. This is now negative. I factored out. So again, put the negative out front. In fact, let's go ahead and just put the negative way out front. And then we still need to factor that denominator. So we flipped, put the negative out front for the numerator. Now the denominator, we've got 3x and x. We know that the only factors are 1 and 2 here. So I have to figure out which order. Well, the signs are different. Might need to switch the signs too. But let's go ahead and give it a try. Let's just put 1 and 2 in and see where it goes. Outer, negative 6. Inner, positive 1x. Is that giving us negative 5? Bingo, on the first try. If it didn't work on the first try, I would have just adjusted, maybe moving the signs or moving the numbers. But both the signs and the numbers worked the first time. That was just a lucky strike. So now that we have that one factored, well, we notice it's not matching the numerator. That's because we didn't factor the numerator yet. So leave the negative out front. This is the difference of 2 squares. X plus 2, x minus 2 are conjugates. The square root of x, the square root of 4, 2, over 3x plus 1 and x minus 2. The x minus 2, now you can see, cancels. So our answer is negative x plus 2 over 3x plus 1. And the parentheses are not necessary at this point. To find where it is undefined, we would just say, hey, 3x plus 1 is equal to 0. Well, x can't be 0, so x can't be negative 1/3 in that particular case. So here is our reduced expression, and then the negative 1/3. And if you don't factor out that negative, if you don't flip it, you're going to have something different than my math lab. If you were in a quiz or a test, I would give you almost full credit, but not quite. My math lab would count it all wrong, so you'd have to wait for me to check it to give you any partial credit on that. Okay, next one up. We already have a negative out front. Okay, can we reduce anything here? No, we can't. So this is already simplified. So all you can do at this point is say, hey, this is the answer. Could that happen? It can. It's kind of rare, but it could happen. And at this point, we would just say that x plus 9 cannot equal 0. So x cannot equal negative 9. That is where it would be undefined. And we'd be finished. So we would just say it's already simplified. And they're just trying to see if you might cancel out some x's or do something. But it's already done. Okay. So I hope this was helpful. And you can certainly join me for Schoology conferences. Just check the times. It should still be 11 o'clock. Hope to see some of you there for question and answer. Bye now.